Welcome to This Explainer. Today, we're doing something wild. We are embarking on a stunning 4.6 billion year epic of creation. We're going to trace the absolute genesis of our home planet, taking us all the way from a silent, dark expanse of deep space to the vibrant, living world we know today. Because before there was an Earth, a sun, or even a solar system, there was only this: a colossal, swirling cloud of dust and gas drifting out in the void. Just to wrap our heads around how we actually got here, we really have to appreciate the breathtaking chronological scope of it all. We're looking at a timeline where exact moments of violent, cosmic catalysts completely transformed our neighborhood. We start 4.6 billion years ago in the solar nebula. We plunge into a hellish magma ocean around 4.5 billion years ago, and we eventually arrive at the miraculous spark of life 4 billion years ago. Okay, let's dive right into this. Our roadmap for this explainer breaks down into 5 main eras. First, the solar nebula. Second, chaos and accretion. Third, Earth's molten core. Fourth, the Theia impact. And finally, oceans and early life. As you'll see, each intensely violent era directly triggered the next stabilizing phase of our planet. All right, Era 1, the solar nebula. This is our cosmic beginning. Picture our little corner of the universe as just pitch black. It was filled with a colossal cloud of stardust, born from the remnants of older, dying stars. It literally contained every single ingredient needed for a new world. Then, something profound happens. Triggered by the colossal shockwave of a nearby supernova, gravity took the wheel, sparking a massive collapse. The cloud began to spin faster and faster, pulling matter toward the center. At the very heart of this spinning disk, the pressure and temperature soared so incredibly high that it gave birth to our sun. But the sun didn't eat everything. It left behind this massive disk of glowing debris, and that leftover material was about to start its own chaotic journey. That takes us to Era 2, chaos and accretion, or as I like to call it, the cosmic demolition derby. If you want to know how planets are actually built from scratch, we have to look at that violent, spinning disk of debris and a very specific mechanism called accretion. Basically, it's the process of growth by the accumulation and merging of material through gravity and static electricity. In plain terms, this was the messy, chaotic engine of planet building. It wasn't some gentle gathering of dust. It was completely violent and relentless. Think about it at a microscopic level first. Static electricity causes these tiny dust grains to stick together. Those small clumps form pebbles, which then grow into boulders. Once they hit boulder size, they've got enough of their own gravity to pull in even more material. Over millions of years, colliding asteroids merge into protoplanets. You had thousands of rocky bodies just violently smashing into each other, vying for space in the celestial demolition derby. And out of all that absolute chaos, our young Earth finally emerged. This brings us to Era 3, Earth's molten core, the inferno and differentiation. Let's anchor ourselves in time for a second. About 4.5 billion years ago, driven by extreme heating from the radioactive decay of elements inside it, plus this constant, unending bombardment from space, the young Earth was literally a hellish inferno. I mean, the entire surface of the planet was a vast, hostile ocean of boiling lava. Volcanoes were constantly erupting, spewing highly toxic gases into the sky. It was completely inhospitable. But beneath the surface, something incredibly vital was happening. During this molten stage, we get a critical planetary process called differentiation. Driven by gravity, the heavy elements, like iron and nickel, sank deep into the Earth's interior to forge a metallic core. Meanwhile, the lighter stuff, like silicon and aluminum, floated up to the surface, eventually cooling to form a thin, rocky crust. So why does this matter to us? Because that heavy iron core sank, it became Earth's engine. It actually still generates the powerful magnetic field that shields our planet and us from deadly solar radiation today. But just as the Earth was beginning to stabilize and form this early crust, a massive threat approached from the dark void. Take a second and ask yourself, what caused Earth's greatest catastrophe? What kind of massive celestial body could possibly disrupt this young, stabilizing world? Well, that brings us to Era 4, the Theia impact and the birth of the moon. Imagine a rogue protoplanet roughly the size of Mars, just hurtling through space. Its name was Theia, and it was on a direct, unfathomable collision course with Earth. The impact was cataclysmic. Theia didn't just graze us, it struck the Earth at an angle. The sheer force of the collision instantly vaporized Theia and stripped away a huge chunk of Earth's newly formed outer mantle, blasting a massive superheated ring of glowing rock and debris directly into orbit around our wounded planet. But space is incredibly dynamic. Over a remarkably short period, we're talking perhaps just a few centuries, gravity went right back to work. It pulled this massive ring of orbital debris together to forge our moon. And because it formed from our immediate debris ring, it initially sat much closer to Earth, appearing absolutely massive in the ancient night sky. So this violent destruction directly led to the creation of our permanent planetary companion. Which leads us to our final act, Era 5, Oceans and Early Life, the arrival of water. After the Theia impact, the cosmic bombardment finally began to slow down. The violence dropped off, and a massive atmospheric cooling process kicked into gear. First, as the rocky surface cooled, turning from glowing red to dark gray, it released trapped steam and volcanic gases, creating a super thick shroud of clouds. Second, millions of comets and water-rich asteroids from the outer solar system rained down, basically acting as a cosmic delivery service for vast amounts of ice. Finally, once the temperature dropped enough, the atmosphere hit a tipping point and broke. For thousands, maybe millions of years, torrential global rain fell, filling the deep basins of the crust and creating our very first oceans. That brings us to our final crucial timestamp, 4 billion years ago. The stage was now perfectly set. Earth finally had a solid crust, protective greenish-blue oceans, and a thick atmosphere. And deep within those primordial seas, near the glowing, mineral-rich hydrothermal vents on the ocean floor, the most miraculous chapter was about to begin. Down in the murky, totally dark depths, simple chemical compounds began to interact. Fueled by the minerals spewing from these hot vents, they formed the first self-replicating organic molecules. Life had officially begun. Now, sure, it would take billions of more years of tectonic shifting, atmospheric changes, and biological evolution to create the continents and the oxygen-rich biosphere we enjoy today. But that initial spark, it happened right here, deep underwater. I want to wrap up this explainer by reflecting on a quote directly from our source material today. The story of Earth's creation is truly a testament to cosmic chaos, violent destruction, and the perfect balance of conditions. It leaves us with a totally fascinating, provocative thought to ponder. If a hellish, molten inferno of crashing space rocks can perfectly balance itself out to become our incredibly vibrant living oasis, you really have to wonder, what other perfect balances might exist right now, waiting to be discovered out in the vast, dark void?